Welcome to The Explainer. You ever finish a meal and wonder where does all that energy actually go? Well, today we're diving into glycogenesis. It's your body's brilliant way of banking that fuel so you can use it later. Think of it as your personal energy savings account.
All right, here's our game plan for this explainer. We're going to start with the basics. What is this thing? Then we'll look at where the energy gets stored, who's in charge of it all, and then, my favorite part, we'll walk through the actual step-by-step assembly line. And finally, we'll wrap it all up with why this matters so much to you every single day.
Okay, let's jump right in. To really get a handle on this, we've got to start with the big question. What in the world is glycogenesis?
So at its heart, the idea is actually pretty simple. Your body takes all these tiny little sugar units from the carbs you eat, that's glucose, and it starts linking them together, kind of like snapping Legos into place. It builds this big, branching molecule called glycogen. That's it. That's your body's #1 way of putting carbohydrate energy on layaway for later.
Okay, so if your body is building up this awesome energy reserve, where exactly does it keep the stuff? And, what's the signal to actually make a withdrawal from this biological bank?
Now this is super interesting. We've got this dual storage system. Your liver? Think of it like a generous community bank. It stores glycogen to release glucose for everyone, making sure your entire body, especially your brain, has a steady supply of fuel, and your blood sugar stays nice and stable. But your muscles? They're a little more selfish. Their glycogen is a private stash, locked away for their own use. It's that immediate, high-octane fuel they need when you're working out.
Your body is incredibly smart. It doesn't just dip into these savings for no reason. It waits for those high-demand moments. We're talking about intense exercise, like sprinting or lifting weights, or when you've been fasting for a while, even when it gets really cold. That's when your body says, okay, time to break down the glycogen and get that quick energy we need right now.
Of course, a process this important isn't just left up to chance. Oh no, it is tightly controlled by a team of hormonal supervisors, basically telling your body exactly when it's time to save energy and when it's time to spend it.
And this slide just illustrates that push and pull system perfectly. On one side, you've got hormones like adrenaline and glucagon. They're the ones screaming, release the energy, authorize the withdrawal, for when your blood sugar is low or you're in a stressful situation. But on the other side, you've got the master of storage, insulin. Right after you eat, when sugar floods your system, insulin is the one that knocks on the door of your liver and muscles and says, hey, we've got a surplus, time to make some deposits. It's the main driver of glycogenesis. All right, let's get into the real core of our explainer. We're going to dive into the nitty-gritty and actually watch how a glycogen molecule gets built, step by step. So yeah, welcome to the assembly line.
I want you to picture a tiny, microscopic factory floor. Our raw material is just one little glucose molecule that's floated into a cell. But it can't just be slapped onto the pile. Nope, it has to go through some serious prep work first.
So these first 3 steps are all about getting that glucose molecule ready. First, a little energy tag gets attached to it. That not only traps it inside the cell, which is clever, but it gets it ready for the next step. Then, that little tag gets moved to a different spot. And finally, and this is the key part, the molecule gets activated. It basically gets a high-energy handle attached, turning it into UDP glucose. Now it's an energized, easy-to-grab building block ready for construction.
So here's the thing. You can't just start building one of these energy chains out of thin air. The whole process needs a foundation, an anchor point. And that's where this special protein called glycogen kinase comes in. It's a total self-starter. It literally builds a short little chain of glucose right onto itself, creating the perfect launch pad for the main event.
Okay, once glycogen has laid that foundation, the master builders get to work. First up is glycogen synthesize. This enzyme grabs those activated glucose units we made and adds them to the chain, one by one, making it longer and longer. Then a specialist comes in, the glycogen branching enzyme. It does something really cool. It snips off a chunk of the chain and reattaches it to the side, creating a branch. It's these branches that make the final molecule so compact and efficient, letting you store a ton of energy in a tiny space.
Whew, okay. I know that was a lot of biochemistry. So let's zoom all the way back out and talk about the big picture here. Why is this molecular factory so incredibly important to your everyday life?
Look, here's the bottom line. Glycogenesis is the bridge between eating a meal and needing energy hours later. It's what keeps your blood sugar from going on a wild roller coaster ride. It's what loads up your muscles with the fuel you need to go for a run or pick up your kids. Honestly, without this process, we wouldn't have any real energy reserves. It is just a fundamental pillar of our metabolism. When you really think about it, this whole system is just an absolute masterpiece of efficiency, perfected over millennia to help us survive. And that really just leaves us with one final thought to ponder. In our modern world, where food is almost always available, what happens when this incredibly fine-tuned energy storage system is constantly being pushed into overtime?